Okay, here's kind of a video solution of how I did the three problems. Problem number one was to draw a hexagon with a side length of 8. Okay, so here's kind of how I did it. And again, this is me physically doing it just with a ruler. The video would have been way too long if I actually showed me actually doing all of the steps. Okay, first, for a regular hexagon, I know the interior angles are 120, which means I know the exterior angles are 60 degrees. Okay, this is going to be a key step. So what I did first is I remember that for a 60-degree angle, again, exterior, this angle right here is going to be 60 degrees. That's my exterior angle. Okay, so I took my ruler and I made that guy 8 centimeters. Okay, so then I started and I have 2 of the 6 vertices already, and I just labeled that 8 centimeters. Okay, and then what I wanted to do, I know that I need this to be 8 centimeters and I need that angle to be 60 degrees. But I know that if this needs to be 8, that this needs to be 4. Again, because of this. I know that a 30, 60, 90 triangle, the short leg is half the hypotenuse. So since I wanted that to be 8, I wanted that to be 4. So I went ahead and drew that to be 4. And then I have to go up 4 radical 3, which is just a decimal. I think it was like 5 point, or no, it was like 6.43. Let me do it real quick on the calculator. I didn't write that down. 4 times radical 3 was 6.93. Okay, so I went up 6.93, and then I made a mark. And then I checked to verify that that is in fact 8 centimeters. And then I just did the same thing on all of those. I did the same thing over here. I made that 4. And if that's 4, this is 4 radical 3. That guarantees that this thing is 8. And I just connected the dots and made it 8. And then once I had those two, right, I have an 8 and an 8 and 8. And then I actually thought it was kind of fun that I would know that the distance here is just 2 apothems, right? If that's the center, then that's 1 apothem and then that's the other apothem. But I know that if the side length is 8, the apothem is actually just 2 of those. So 8 radical 3. So actually I just went straight up 8 radical 3 from there and 8 radical 3 from there, and then I connected, and all of a sudden I have a hexagon with 6 sides that are all exactly 8 centimeters. And again, you can check any of them you want. They're all exactly 8 centimeters. So that's how I did a hexagon. I really would just used my 30, 60, 90 triangle stuff. Okay. All right. Octagon. That's how I did my octagon. All right, the goal was to make an octagon of 5 centimeters. Okay, so I just went ahead and made 4 of the vertices right away. Okay, so I made the center, and then I put a mark at 0, and I put a mark at 10, and a mark at 5, and that got me the center of the octagon and 2 of the vertices. And then if I had a compass, I could have went perpendicular. I guess that's an assumption that I can draw perpendicular lines. And then I went a 10, a 5, and a 0. And so what I have here, these and those, I drew. Okay, and I just made those 5. Okay, after that, I went ahead and I knew that the exterior angles are 45 degrees. Okay, so what I need to be able to do is I need to be able to bend up 45 degrees. And so I know that if this is 5, for a 45, 45, 90 triangle, if this is 5, that's 5. So if that went over 5, and that went up 5, then I just need to connect that dot. So I didn't know where on this line. Okay, I went over 5 and up 5, and then I just connected that. Okay, and so I know then that vertice, I know that this triangle is a 45-degree triangle, 5 and 5. And then I just went ahead and then measured 5 from the center on the pink line and then put a dot. Thus, for sure, this is 5 centimeters long, like it's supposed to be, and this angle is 45 degrees. And I know that the central angle in an octagon is 45. So I guess I should write that down. Really what I did here is I used the fact that the central angle was 45 degrees. which it does happen to match the exterior angle, but I really use that. And then I did it here and here and here. So once I did one, the same thing for that one, the same thing for that one, the same thing for that one. Again, the key step is knowing that this needed to be a 45-degree angle. The original 4 were all 90 degrees, and then I need to split them each into half, which is 45. 5 over and 5 up. I connected this line to find the 45-degree line, and then on that line, I just wanted to go out 5 centimeters. And so all of these are then 5 centimeters away from the original. Okay? So again, I know that octagon might not look, a lot of people want the octagon to look like that, where I drew it flat, but the way I did it was this way. And again, it doesn't have to be the only way, but that is a way. All right. And then my last one was my pentagon. Okay? Pentagon I actually broke down and I had to use some trig. I'm sure there are other ways to do it, but I thought this was kind of a fun way. So what I did is I want an apothem of 4. So I want, in my little triangle, I want that distance to be 4. And I know that the interior angle is 108, which makes that angle 54. So if that angle is 54 and the apothem is 4, then I went ahead and I could figure out then what x is and r is using trig, just like we've done before. And then I can find the side length of 5.82. Okay, so here's what I did from there. Okay, so I made, you can see, I made the side length 5.82. And then I know that the exterior angle is 72 degrees. So if that's 5.82, okay, this distance is 5.82, all I really needed to do was figure out this distance and this distance. Remember, exterior angle is 72. So down here, I know that it's going to go 5.82, 5.82, 5.82. So like this 5.82 is this. And so I wanted to go this at 5.82. So I wanted to figure out how far over and how far up to go. So I just went ahead and did some trig to figure out 1.8 and 5.54. So if I want to go up at 72 degrees, all I have to do is go over 1.8 and up 5.54. And then I know that that intersection will be exactly what I want, 5.82. And then I did the same thing here. And then this one was kind of fun because this distance is the apothem, but this distance is actually the radius. And I found that already right here. And so from this guy, I just went from the center straight up, and I went, this is the apothem, of course, and then that's actually the radius. So I found those two were my original line segment. I found these two the same way, and then I found that guy by doing the radius and the apothem, and then I just connected the dots, and now I have a pentagon that are all exactly 5.82, and they are really close, certainly within any normal realm of error, they would work. So I kind of used trig, I used special right triangles, I used a 30, 60, 90 on one, and then I used a 45, 45 on the other, and then on this one I just busted up some trig. I used a central angle on one, I used an exterior angle on one, so hopefully this gave you some variety, and again, hopefully watching this video gave you some ideas on how to draw yours.